Hi, welcome back to ScottiesTech.Info. I'm Scotty with my co-host Cletus. So, you've probably heard about SAR, or Specific Absorption Rate. Now, this is a measure, like when you're buying, say, like a smartphone, a cell phone, you might look at the SAR rating. And SAR is basically going to tell you how many in watts per kilogram, how much RF, how much radio frequency energy is going to be absorbed by your body. So they'll usually say, like, you know, this smartphone has a SAR rating of 0.8 watts per kilo for the head and 1.0 for the body. There's multiple different ratings. Ratings in countries differ a little bit. There's different limits allowed for Europe versus the United States of America, for example. So in any case, many of you have probably, when you're looking for a smartphone or even a dumb phone, you probably look at SAR rating and you go, well, this one has a SAR rating of 0.3 and this other one is like 1.0, so I'm going to get the low SAR phone because it's going to blast me with RF less, right? So you think it's safer. Turns out that's not actually correct. So first of all, let's take a look at specifically how SAR is measured. Like, what do they actually do to get this rating? So this is an FCC SAR Test report. It's for an Asus, I think it's like a Zenfone, something or other. Right. It's 135 pages long, and basically it's a summary of what they do when they actually get this SAR rating. Now, it gets really, really hairy, so I just want to show you a few little parts in here. You can check out the table of contents. There's, like, you know, RF exposure limits, what exactly what SAR is, how they set it up, how they do the measurements. There are like 70 or 80 pages of tables of like different results and stuff, but we're just going to look at a couple little key parts. So the first thing we're going to do is we're going to look at this RF exposure limit setting. They're kind of, you know, babbling, uncontrolled environment, controlled environment, blah, blah, blah. But down here at the bottom, we have this little highlighted bit here that says, whole body SAR is averaged over the entire body. Partial body SAR is averaged over any 1 gram of tissue defined as a tissue volume in the shape of a cube. SAR for hands, wrists, feet, and ankles is averaged over any 10 grams of tissue defined as a tissue volume in the shape of a cube. So right here we see that they're not actually testing how the phone affects your body. They're testing how the phone transmitting, whether it's using, you know, 2G, 3G, 4G, 5G, Wi-Fi, Bluetooth, any and all radio transmitters in the phone, they have to test. They have to test them individually. They have to test them together, so on and so forth. But they're not actually testing it on a human body, of course. They're actually using a tissue sample. Now, just keep that in mind as we go on here. Now here is kind of a definition of the specific absorption rate, and in the introduction they write, SAR is related to the rate at which energy is absorbed per unit mass in an object exposed to a radio field. The SAR distribution in a biological body is complicated and is usually carried out by experimental techniques or numerical modeling. Well, actually they do both. Now, of course, if you want to look at the crazy math, you can have some fun there. On the next pages, this is just an image of the setup that they use. As I said, it's pretty ridiculously complicated. You don't have to remember that. I just wanted you to kind of see, like, these tests are insane, like the amount of stuff they do. So then we come down, and this is like the E-field probe. This is like the special probe that's used to, like, measure blah, 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 you know, data acquisition electronics, so on and so forth. And if we keep coming down here, we see this little thing, the ELI phantom. Like, well, what is phantom? What is a phantom? This is the thing that actually holds the tissue sample. Yeah, this little image in the center of the page there, that doesn't really look like a human head or a hand or a wrist, does it? That's a little bit... And here we have the device holder. Everything is, you know, computer controlled and precisely aligned, and we'll see exactly what they do in a second. But as you can see, it's extremely complicated. Now, this tissue thing is a little bit odd, so we come down here, and in the zoom scan section, we read, zoom scans are used to assess the peak spatial SAR values within a cubic averaging volume containing 1 gram and 10 gram of simulated tissue. Remember that, simulated tissue. So what they're actually doing here is they're using kind of like tissue juice. It's like not a real human head or hand, or it's like a little bowl of like tissue juice. Yeah, that sounds highly scientific. So here we go. This is showing you like, okay, this is like a simulated head. They actually do like a whole series of different tests when it's at different angles and different positions in relation to like your left ear, your right ear, your left cheek, your right cheek. Here you have definition of the cheek position, and you can see like depending on the shape of the phone and this, you know, there are all these very, very specific requirements. So it looks extremely thorough. Now let's just jump to page 73 here, and you can see the beginning of some results. Now, as I said, there's like, you know, like 80 pages of these tables, and these are all the different results. Now the thing to note is you have, you know, your plot number, and then you have band. Now the band will vary. Like this is GSM 850. That's the GSM system, which is used in Europe mostly. Well, actually, pretty much most of the world. It's less popular in the United States and North America. But GSM 850 is 850 megahertz, the GSM scheme. Mode GPRS2 is, and you can see right cheek, right tilted, left cheek, left tilted. The gap between, you know, the body part and the blah, 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 blah. And then in the far right column, you can see the 1 gram SAR in watts per kilo. And you notice like these values, like even for the same frequency and kind of modulation scheme, or, you know, for the same antenna, the values can vary sort of wildly. Like in one you can have 0.155, and then another you have 0.9. And you can see here, let's go to page 75. This is it. So here you can see you have tests for LTE band 5 antenna 3, LTE band 7 antenna 1, and here you have the modulation is QPSK. Now that's again different modulation, different frequencies, different. They have to test every single individual thing that the phone is capable of, including Wi-Fi and Bluetooth and all the radios, as I mentioned. But you can see here, like LTE band 7 antenna 1, QPSK right cheek 0 millimeters. The SAR value is 0.001. Okay, well that's pretty low. Then you come down here, LTE band 7 antenna 4, QPSK right cheek 0 millimeters, 1.072. So as you can see, these results vary pretty wildly, and that's important. So in short, when they do a SAR test, what they do is they take a tissue sample / liquid, and they use it to simulate human tissue. They do a whole ton of measurements with all these different radios and all the different modulation schemes and all the different frequency bands and all that. And they say, okay, well, how much RF energy is absorbed in this, you know, this 1 gram of tissue, like, and then they calculate and model, and like they do all kinds of crazy stuff. They have like calculated averages, and out of all this they get a max value, and the maximum value is the one value of all those like gajillions of tests they do. Like, what is the absolute highest value they get for that specific situation, that specific frequency modulation, blah blah blah. So then they say, boom, this phone has a SAR rating of 0.6 watts per kilo. Okay, but hang on a minute, isn't this a little weird? I mean, they're using this like tissue juice. That's very different from a human body. I mean, if I have a phone and I'm holding the phone up to my head, well, my head is different than your head. What if I have, say, you know, like old mercury fillings or something, or, you know, the density of the bone in my skull might be, you know, I may have a thick skull because I've got a tiny brain, right? I may be ill. My head may be full of snot or something, right? All of that stuff could sort of change the ratings. Like, you have to understand, when you do EMF testing, like, it's insanely complicated. It would be pretty much impossible to model. You're using like a supercomputer, the world's biggest supercomputer. You pretty much couldn't actually model the human body, and even if you could, you'd have to model everyone's human body, because everyone's body is slightly different size, shape, you know, maturity level. Cells are still developing, cells are not developing. You have, you know, whatever. There's so many variables that to say, well, let's just use this little tissue sample, boom, there we go, we measured power levels and we're happy. Now, the next thing is that it's kind of interesting that they're talking about a tissue sample, because those of you who have read some of the over 1,000 studies at this point showing that things like, wireless tech like 2G, 3G, 4G, 5G, Bluetooth, Wi-Fi, whatever, maybe 5G, maybe it's not so safe, right? And invariably what happens is someone comes out of the woodwork and says, yeah, but that study, it's crap because they didn't test it on a real human body. They tested it on a tissue sample. You're going, right. But the FCC came up with standards, and what they're doing is they're saying, yeah, you use this tissue sample to simulate the human body. So the official regulations that are in place use tissue samples to argue that it's perfectly safe, and yet when perfectly, intelligent and capable and sometimes genius level scientists and engineers and doctors and researchers actually do a study to show that, no, maybe this stuff is not safe, they're poo-pooed because, no, you used a tissue sample or a mouse instead of a real human being. That's kind of problematic. You can't have it both ways. But let's see what the FCC itself has to say about the SAR rating. So there's a really interesting little guide released by the FCC itself, and it's entitled Specific Absorption Rate for Cell Phones, What It Means for You. And it's in this little paragraph right here. It's kind of an interesting read. All cell phones must meet the FCC's RF exposure standard, which is set at a level well below that at which laboratory testing indicates, and medical and biological experts generally agree, adverse health effects could occur. Well, not all medical and biological experts are in general agreement. Yeah, we'll just let that one slide. For users who are concerned with the adequacy of this standard, or who otherwise wish to further reduce their exposure, the most effective means to reduce exposure are to hold the cell phone away from the head or body and to use a speakerphone or hands-free accessory. These measures will generally have much more impact on RF energy absorption than the small difference in SAR between individual phones, which in any event is an unreliable comparison of RF exposure to consumers given the variables of individual use. Oh, wait a minute. So, okay, what? So they come up with these SAR measurements and they're like, yeah, blah, blah, blah. But they just admitted that the SAR measurements are actually completely useless. First of all they're measuring is like the power, like how much this radio frequency energy, 800 megahertz, 900 megahertz, 2 gigahertz, 3 gigahertz, 6 gigahertz, whatever. How much of that energy is like heating tissue, like in your noggin, for example. That's all they test. They don't look at modulation schemes. They don't look at like the pulsing nature of digital transmissions. They don't look at all this stuff that other studies have called into question. Okay. Now, as I mentioned, there are so many variables with this stuff that it's actually insane. So what the FCC is actually saying is that the SAR rating between two phones is actually completely pointless. So say I have two phones here, right? Like, okay, here are my two phones. Now, I want to know which one of these I should buy. And let's say like, well, this one has a higher SAR rating and this one has a lower SAR rating. Okay, so, well, I would buy the phone with the lower SAR rating, right? Not so fast. Because as we've just seen with the SAR test reports, it's entirely possible that this phone has a higher SAR rating and this phone has a lower SAR rating, but that's the one measurement that was the absolute highest. So it might be that, let's say, okay, different modulation schemes and, say WCDMA versus GSM. Well, I live in Europe, so I'm going to be using GSM, not WCDMA, right? But the reason that this phone has a higher SAR rating than this phone is because this phone in the WCDMA test had it was like 1.2 watts per kilo, whereas this one was like 0.3. But only for WCDMA and only in a specific frequency band and only in cheek position like this, not like this, or, whatever. That one reading in that, we'll call it a modulation scheme that I'm never going to ever use because I live in France, right? That gave this phone a higher SAR rating than this one, so this one appears to be safer. The problem with that is that, yes, for that specific instance of WCDMA, this phone blasts my head more, but I'm going to be using GSM with this phone that has the lower SAR rating, so I buy this phone and I use it. But what I don't know is that this phone in the GSM tests is actually blasting the crap out of my head but it has a lower SAR rating. For the specific GSM, at the specific frequency bands, in the specific position, this phone with a lower SAR rating in GSM could be blasting me more than this phone that has the super high SAR rating, making it evil. In other words, it is nowhere near as simple as a single number that can compare the SAR ratings. You know, this phone is safe, this phone is more safe, this phone is less safe, let's say. So that's what the FCC has actually just admitted there. And also for, you know, any given phone, the SAR rating is kind of useless. Like, you know, as I said, you have like the angle that you're holding it, the modulation scheme, the frequency, the power levels, you know, am I using, say, you know, 4G LTE at a certain band, and is the Bluetooth on at the same time, or is the Bluetooth off? That can make a huge difference in the amount of, you know, what is actually happening to my brain when I'm holding my cell phone up to my ear. You know, as I said, you know, do you have fillings? Do you have like a congested head? Do you have just normal variations in body chemistry? Are you taking some medication? Well, you can't test medications in a tissue sample, but yet some medications go all throughout the body and can have, you know, rather dramatic effects. Like, we don't know because we haven't tested it. They just use a tissue sample, some tissue juice, and they blast it in this extremely elaborate setup. But the only thing that it's actually designed to prove, let's say, is that yes, according to these standards, basically from the 1970s, yeah, maximum power level, blah, blah, blah. Yeah, the phone is safe. It's below the 1.4 watts per kilo limit or the 2.0 watts per kilo limit if you're in Europe, or whatever standard they set. So basically, SAR measures the highest power. It says nothing about the actual typical real day-to-day, real-world use of that phone. And as such, even for a given phone, it's pretty much useless. Now, numerous studies have shown that even tiny power levels in the picowatt range have certain biological effects on tissue samples, of course. And as we've just seen, tissue samples are a perfectly scientifically valid thing to use, because if the FCC is using them, well, then the researchers questioning 5G can certainly use them. Of course, then you have questions about the quality of those studies, which is the next most popular thing I hear. Well, did you read the study? Did anyone else read the study? Did anyone look at the study and go, I'm a scientist, we should do this the way that science is done? In other words, I've got a pile of 50 papers on my desk, published scientific papers saying, yeah, maybe this stuff isn't as safe as we thought it is. Maybe what I will do is try to repeat their experiment, which is generally how science is done, and if the results are repeatable, then I'll add my voice to the pile and go, yeah, maybe we should look at this stuff more. But that isn't what happens, because there's no money in repeating an experiment that shows that this stuff is maybe not safe for us. Now, I don't know if it's not safe. I don't know that it is safe. I don't know that it's not safe. I simply have questions based on the studies that have been published, and I don't think it's a bad thing to actually ask that question. So, at the end of the day, well, how do you pick a cell phone or a smartphone, a dumb phone, whatever? You just pick the one that you want. Cost, features, whatever. And these days, you can't get away from it. If you want to access your bank account, you must have a smartphone. That's increasingly common. You're pretty much not going to get away with not having one. Like, you must have one. And yeah, for me, the simple solution is just whatever phone you have, just get it. Use a wired hands-free thing. Keep it as far away from your body as possible. If you have the phone and you have it in your pocket, don't put the screen facing out. Put the back side of the phone facing out, because typically the antennas are on the back of the phone. Transmit away from your body, not into your leg or into your chest or something. Don't have it on if you don't need it. Don't have Wi-Fi and Bluetooth and everything turned on if you don't need it. When you're at home, use a wired network. Run some Ethernet cables. Boom, you're done. No more Wi-Fi in the home. You just minimize your exposure. And it's kind of like minimizing your exposure to other potential toxins, like you have, water. Does your water have contaminants in it? Well, then you use a purifier. Nobody thinks you're crazy and calls you a conspiracy theorist because you use a water purifier, because, well, you can just test the water and you go, oh, yeah, this looks not very good. And, of course, the city officials say, oh, no, it's perfectly safe. Well, of course they're going to say it's perfectly safe because, they don't want to lose their jobs, and you know how these things go. You just take precautions, you protect yourself, and hopefully as time goes on, more and more people will become interested in this stuff and look at it, and we will have some final, more definite answers as to, is this stuff safe or not? Right. I guess we'll find out. Right, so that's SAR levels. Next time you buy a phone, just totally ignore them because they're utterly useless. For more techie tips, see ScottiesTech.Info. Thanks for watching. See you next time.